you have questions, we have a chat box that probably is the best, but also feel to chime in with a voice question with a number of people. I'll try to be a little bit brief with your question, but I'll be happy to answer them. And if you have something after, be sure to send me an email and I'll respond there too. Of course, I need to thank those people, those groups that make this possible. Again, Utah Governor's Office of Energy Development. That's who pays who. They don't pay for them all, but with Rocky Mountain Power, Dominion Energy, and Department of Energy through the Governor's Office of Energy Development, these are made available at no charge. So that's great for everybody. And it's an effort to get everybody on the same page as far as energy code goes. And for years, I don't know how many years, Alyssa, we've been working together, but it's been a number of years. I've worked with Alyssa Kay at Salt Lake Community College Energy Institute, and we simply could not do this without their support. And so I want to just turn a minute over to Alyssa so she can share a few thoughts on her Energy Institute, and then we'll move on with the presentation.
Thanks, Brent. It has been a pleasure working with you, and I look forward to continuing to work with you, hopefully more in person over the next year. So just a little bit about the Energy Institute at Salt Lake Community College. The Energy Institute is an award-winning program that provides a fast track to careers or career advancement in the building, engineering, facilities, HVAC, lighting, and clean energy industries. All of our instructors are highly qualified professionals who currently work in their respective fields, and our curriculum is developed by industry experts, ensuring that the content is current and relevant. So we do start courses multiple times a year. We're starting a new term this week, and here's what we're offering. Enrollment is open for the Energy Management AAS degree, which covers residential, commercial, and industrial energy efficiency, including HVAC, lighting, automation and controls, and financial analysis of energy investments. We're proud of our over 200 plus alumni who have gone through this program in the past 10 years and who are now working to save energy and save money throughout Utah and throughout the United States. In addition to the Energy Management AAS degree, we also offer shorter certificate programs as well as one-day training programs. And so starting this week, our solar certificate is being offered. We offer a solar certificate in installation and in cells. And the certificate is mostly online with live broadcast lectures and online content with Saturday trainings at our new solar training yard at the West Point campus out by the airport. Additionally, we have courses starting this week in energy modeling, industrial energy, selling energy efficiency, and building automation and controls. So if any of those sound interesting to you, you can contact me at slcc.edu/energy, and I'll go ahead and put that link in the chat as well, or just hang out after the presentation and I'm happy to answer any questions. So without further ado, we'll get started and let Brent share his expertise with you. Thanks, Brent.
Thanks, Alyssa. And I know we've had people join on since you made the announcement. I'll repeat it for you, Alyssa, that for Doppel credits, they need to have their camera on.
Thanks, Brent. Yes, and also I'm posting the file presentation of the slideshow again in the chat for anyone who hasn't downloaded that yet. Thanks, Brent.
Yeah. Okay. As we're talking about amendments to the code, I thought it would be nice to start with the most recent amendment to the code, which was just signed by the governor in the past week. And that is Senate Bill 33, which adopts the 2020 National Electrical Code, or the Commercial Electrical Code that we use in Utah. But of course, the legislature can't run a bill without attaching a bunch of other stuff to it. And so what key to our discussion here is that Senate Bill 33 also moves the review of the 2021 IRC to next year. So typically what we have been doing, and in fact, right now, the Building Codes Commission and the advisory committees are reviewing the commercial codes, the IMC and the IBC, all the various codes, except for the IRC. We skipped the 18 IRC. Well, we're not going to review it until next year, which makes the earliest possible adoption of a new revised energy code being July 1 of 2023. So that will make 7 years that we'll be on basically the same energy code that we've been on, with slight modifications as we've gone through the years. And many of you know that I'm not a big fan of a weaker energy code, that I support a robust, current energy code. I think there's value to it. And I've been a little vocal about my disapproval with what the legislature's done. But I think it's important for us to think a little bit at this point, where we have 2 more years on basically what we're considering our residential energy code. As we approach this 5th year, completing this 5th year on the current code, how are we doing with that code? Are we 15% compliant, 20% compliant, 50% compliant? Do you think we're 90% compliant? I guarantee you across the state, we are not 90% compliant with the current energy code. Those gentlemen out there, and I see several that are HERS raters, call me all the time, and they're going into subdivisions and areas where there's no attempt to enforce any form of the energy code. I received a phone call just about a month ago from a homeowner that had extremely high utility bills, and he has a brand new home with a vented crawl space with no insulation in the floor or of that home, and no duct insulation. Now you think about that, and it was a long home with a furnace at one end, so there's all this sheet metal duct that ran the full length of this vented crawl space running through outdoor air. So we have our compliance with the energy code is all over the board. There's jurisdictions that are doing well, there's builders that are doing well, there's design professionals that are doing well, and then there's on the other end some that aren't doing quite so well. So my focus today is what amendments we have, and also a focus on maybe let's not worry about if it's going to be 2 years or even more before we go to a new code. Let's worry about becoming a little bit better at building a more efficient home today, and build it at least compliant with the current requirements in our state. And there's a lot of issues, and we'll talk about some of those as we go through. There's no question building departments are busy right now, and they're struggling for enough people. But I dare say that the same building departments and their inspectors, they go into a home and they call, regularly, things about the electrical outlets and other things throughout the house, spacing, enough space for the toilet and everything. And sometimes we just need to remember, we just can add to that list, half a dozen or a dozen things that we need to check when we go in and do an energy inspection, and to be thinking about energy when we enter that home. Now, many of you are familiar. If you're not, I want you to know that we have a handout, and it's a little 1-page handout, and it's a residential guide. And many of you have seen this. Well, we just updated this guide, and the previous guide had, if you, and I don't know if you can see my cursor, but if you start over, in fact, can you tell me, can anybody see my cursor? Okay, great. I'll use it then if you can see it. So we start over here And I have a note here that this includes amendments effective July 1, 2021. I have eliminated all the text that talks about all the steps that we have made to get to this point. So starting off right here at the first, again, red text and indicates an amendment. And number 5, I just say the 2012 Utah Res Check has to pass by 5%. And I eliminated all the verbiage that talked about the previous steps where we went from 3 to 4 and now to 5. So throughout the whole document, that's what's occurring. Now, if your screen's not as big as mine, you probably won't be able to read this. And so I'm going to break this down, and I'm going to go through each paragraph or each section of this one by one in our presentation today, with a special focus on the amendments, but just also to just focus on the basics of the energy code. Now, you can download this document at utahenergycodes.com, and I want you to know that that's available there as a resource. This is a fairly new site, and we are trying to update it and to add content to it. And let's just talk a little bit about that. So when you open the website, this is what you'll see. And you'll have that graphic, that picture on the screen will cycle through different components. But what I want to focus on first is our menu bar across here. We have residential code resources. We have commercial code resources. We have live stream, which would take you to where we are today. We have energy code blog that we've started recently, and that's where I answer questions or other people answer questions that might be useful, and how to get a hold of us. And of course, you can get a hold of me by simply sending me an email or a text. And so going to the residential code, when you click on that one, you will find residential energy code resources and training videos and materials. So going to the next step, under energy code resources, we have our residential quick guide. That's the document that I just brought up on the screen. The 2015 energy code amendments. And so those are actual pages out of the code that identify the amendments. And so you can see where they are in the code, and you can actually, it makes it a little bit easier to read your code book. Now, that one has not been updated. It's going to be updated within the week to show the most recent one. I've been waiting for the legislature and the governor to finish. And so that one will be updated shortly. And then we have another document, residential compliance pass. We have 5 paths to show compliance: HERS rater contact information, and an air barrier installation table that comes out of the energy code. Now, while I'm on this slide right here, I just want to remind people, if you're not aware of it, I know most of you may be, but the energy code is published as a separate code book, and the residential portion of that code book is also included in the International Residential Code in Chapter 11. And so where we talk about this table in the IRC, it's, this number is where you find it. If you're in the IECC, it's this number. So my handout, my quick guide, is based on numbers in the IECC, the actual energy code book. If you go to the IRC, you'll see the numbers are quite similar, other than it's in Chapter 11 versus in Chapter 4. So they're identical books, identical information in 2 different books. If you're a builder or a design professional and you have a copy of the IRC, you don't need to buy the energy code unless you're getting into commercial, and then you will need it for your commercial provisions. So if we go the next step, our energy code resources in the residential code section of the website, we have training videos from previous classes Some of them just the slide decks, some of them we have video, and I want you to know they're available for you anytime. If you're teaching a class and you want to use them, use them. These are available at no cost to anybody in the state as part of what community college, myself, Nexent, WC3 are trying to put together to support the energy code. So that's available for you. On the commercial side, we don't have quite as much content there, but we are working on that. And there we have a quick guide that is very brief because the commercial energy code is so complex. And again, the amendments, and then we have some other information there and information on some of the classes there. And then we have also on the next link on the website where you join a live stream. We have a slide deck from a virtual field trip we did last year. You know, after everything shut down, we had to cancel a field trip that we were going to do, and so I have a number of photographs in there that go through a residential energy inspection. Again, if you go there and you see a question or something, feel free to call me and we can go to that slide deck and we can talk about it. And then we have our Utah Energy Code YouTube channel. So on the Energy Code website, we have easy access to guides, new resources that we add monthly. You can ask questions at the website or send them directly to me. And I am trying to post a blog every month now. This is fairly new, where I answer frequently asked questions. And as I mentioned earlier, here's a discussion on the home that I was asked to look at that has a vented crawl space and no insulation in the floor system, no insulated duct. And you can read a little bit more there. In the commercial code, we have a fairly strict requirement for minimizing the amount of piping that we have in our hot water systems in our public restrooms. And so the code has been modified or developed over the years to make sure that when you go into a public restroom, you're going to have hot water and not have to wait 5 minutes to get hot water in that restroom. How do we do a res check on a townhouse? How do we insulate ducts that are in garages in a building? A number of different, and there's a few more than this. So feel free to go to these and refer to those. And if you have a question, and if it's something that I think we need to post up here, I'll do that. And I'm always open to your suggestions. And on our YouTube channel. Now, I'll be the first to admit I've gone through and I've watched some of these, and we've made some mistakes. I've had people ask me questions during the class, and they ask a 5-minute question and you can't hear what they ask. And so as we go back to live presentations, we are going to change a few things and how we do these to make it a little bit more user-friendly for you to watch them after. We are also going to break these down like this. I have a class here that I did on building science, and it was a 7-hour plus class. And we're going to try to break these down into modules. And so we'll identify what the module is. And if you want to watch on, moisture, you can watch the moisture section. And so we're going to improve these. And again, I welcome your suggestions, and feel free to go to the resources. And so that's the website. Let's talk about the energy guide and what we should be doing with our energy code. I get a number of calls asking me for a checklist. I need a checklist so I know what to do at plan review. Or a builder says, I need to know what I need to do to make sure my home's energy efficient. And this checklist can be used as a resource or a guide or a checklist for any of you for whatever your need is. And so here's the start of breaking that checklist down into individual components so we can talk about each one separately. Again, this one, you'll notice that you're on the most current one if it includes this red text statement, January 1, 2021. And the very first item on there is your compliance option. I don't know any other code that has so many options to show compliance. We have 5 different options that you can choose from to decide how you want to comply with the energy code. Now, why would we have so many options? Because we want to build homes that are unique, or we want to have more window, or we want to go overboard on one part of the building, and you want to get credit for that energy efficiency in that portion. And so we do have these 5 options, the first being a prescriptive table, and we'll talk about that table, but it's basically a recipe. And if you follow everything in that table, you comply with the code. However, it limits you on, you have to meet that specific item. If you use a prescriptive table, you're going to have to use 2x6 walls. You're not going to be able to use 2x4 walls, with maybe an exception there, but it's going to be real difficult to do that. But then we go to res check, and maybe with res check where you can trade off and you can have a weaker wall and a better window, or a better attic, or whatever you might want, you can do a trade-off. And so I'm going to be weak in this component, I'm going to be strong in another component. And when you average the 2 together, we're going to have comparable performance to if I built to the prescriptive table. The third one, simulated performance alternative. That's in our 405. That one is energy modeling. And our 405 in that code identifies the standard reference design home that you model against. So you model a standard reference home to the home you want to build. And that has been used in the past to allow people to build with like really poor glass in some cases, or whatever the issue is, you can't get it to pass here or here. Sometimes with simulated performance, you can get compliance that way, where you actually do some energy modeling on your home. The next one is the ERI, or the Energy Rating Index, or HERS path. This one is, and maybe some people will disagree with me, but I think this one is the much improved. Number 4 is the much improved version of 3. The ERI, Energy Rating Index, or HERS score, gives you credit for all the energy you use in your house. This one, on the simulated performance, you basically get credit for your furnace and your air conditioner, and I think maybe your water heating. This one, the ERI path, you get credit for your appliances and other components of your home, virtually all the energy usage in your home. And so that one gives you some advantages, and it gives you a score on your home, an actual reference on how the home you're building or bought compares to other homes. I really hope that someday we are doing some type of energy rating on all of our homes, because it would be a wonderful option to be able to compare 2 similar homes, which one is the most energy efficient. I mean, what is the greatest expense you have on a home after your mortgage? It's typically your energy bills. And so if we have lower energy costs, we have a lower home ownership cost. And number 5 in red is the 2012 Utah Res Check. This is a special res check written just for Utah. And if you use that option, you have to pass by a minimum 5%. Now, item 1, or option 1 through 4, are going to be similar. Whichever option you choose, you're going to have similar performance in your home. Option 5 is a little bit of a loophole. You do not have a home built to option 5 is going to be someplace between 3 and 5% less efficient than a home built in accordance with one of these other options. And we'll talk a little bit more about it, but it basically allows you to do an equipment trade-off. You can build a 2x4 wall with R11, which you think is horrible, but you put in a 96% efficient furnace and you offset it with a high efficiency furnace. We'll talk a little bit more about that. Now, I get calls all the time that someone says, you know, my jurisdiction that I'm building in says I have to do a res check. Is that true? No, that is not true. Some jurisdictions might think that that's the easiest way for them, but according to the code and the way the code is written, you have your choice to pick one of these options, and that's what you must comply with. The other question I receive quite a bit is, well, this checklist and the code says either the 2015 prescriptive table, the 2015 res check, or the 2012 Utah res check. Well, they submitted a 2018 or maybe coming up in the next month or two, a 2021 res check. Is that okay to use that instead of this? Absolutely, because the 2018 and the 2021 code exceed the performance of any of these codes. And so if you want to comply with a more current code, go for it. That's wonderful. You know, you're going to build a home that's even better than a home built to one of these options over here.
Brent?
Yes.
Trent Sorensen is asking about using the 2015 res check. Is that an acceptable alternative?
Yes, it is.
And does it have to pass by a certain percentage?
No, it just has to pass. Yep. Yeah, it just has to pass. I was thinking I had one more thing I wanted to say, but it'll come back to me. Construction documents. Notice that we have a piece of red text in here. And if we go to R103.2 construction documents, there's a couple of things that I really want to focus on here. And anybody that's been a recipient of one of my plan reviews knows that I write up virtually on almost every plan review I do is we have construction documents that have inconsistencies in there. And what I mean by inconsistencies is in a typical residential home, we might receive a res check. We have a set of plans. We have a manual J load calculation. And if we don't have a res check, we have some other form of energy compliance documentation. And sometimes there might be a spec. You know, if it's a large home, the design professional might put a spec together, you know, a spec book. And I go to these documents and I have the R values all over the place. The res check might say that the R value in the walls is R19 or R20, and then the plan says it's R13, and the load calculation says it's R15. And the same thing for the windows. I have 0.33 windows on the res check, but I have on the plans 0.35, or I might have on something else, you know, 0.28. And so it's all over the board. If you're doing a load calculation with incorrect information, then you're going to size the equipment wrong. If we don't have the correct information on the plans, and the information that is correct is on the res check, are we going to be going to the res check when we order windows? No, your window guy is going to go to the plans. And so consistency on those documents is so important. The amendment here eliminated a list. The code has a list of all the various documents that are supposed to be provided. And the amendment put forth by the legislature basically says what the red text says is the construction documents to include all documentation required to be submitted in order to issue a building permit. So as a building official, you have the option to decide if you want them to provide an energy compliance document, but if they don't, how are you going to verify compliance? So I don't think we want to have the whole code book on the plan, but I think the key items that you see missed all the time or that are not done need to be on the plan. If someone decides, if I go back a slide, if someone decides they want to use the prescriptive table for compliance, then put on one of the sheets of the plan, prescriptive table, and list windows are going to be 0.32, R20 in the walls, and just list those prescriptive elements so everybody working on the house sees it on the plans. I see a lot of experience out there, people that have been around the industry a long time. We all know that if we have a good set of plans, we have a much better choice of getting the building built the way it was intended. I like to take the attitude when I do a plan review, could I build this building off this set of plans? Do I have enough information here that I could build the building code compliant and meeting the desires of the customer? There's a number of definitions in the code. I'm going to just pick 4 of them, and these are on our checklist, our guide, and just talk a little bit about these because they're commonly misunderstood. The first one is continuous air barrier. It's a combination of materials and assemblies that stop air from leaking in and out of our building envelope. It can be located inside or outside the building. It can be our drywall if we're making sure we're sealing at edges and at plates and maybe at the in the attic at certain locations. And we'll talk a little bit more about that. Continuous insulation. This one is misinterpreted so often. Continuous insulation is insulation that is only penetrated by a fastener. If you have an attic with trusses and you blow 12 inches of insulation in there, the first 3.5 inches of insulation has a truss, bottom cord of a truss running all the way through it. And people say, well, that's a cavity. But then invariably someone says, well, once we get above that bottom cord of the truss, the insulation is continuous. Well, it's not continuous because it is penetrated by all those intermediate cords on the trusses that are going up and down. And if you take a thermal camera, you can see that. So by definition in the code, by definition in ASHRAE, in softwares that calculate load calculations, continuous insulation only is penetrated by a fastener, and standard trusses is considered cavity insulation, not continuous. So can you have continuous insulation with the truss system? Yeah, if you put continuous on top of the roof, or if you put continuous underneath, on the bottom of the truss. We see continuous insulation on the outside of buildings. If we cover the whole outside of the building with foam, that's continuous insulation. That component is continuous. Cavity insulation is penetrated by something other than a fastener, including wood studs, metal framing channels, or Z-clips or girts or whatever. I see this on commercial buildings. They're putting the mineral wool panels on the outside and they put a Z-girt or something on the outside and they want to call it continuous. Well, it isn't, because we have that metal girt on the building that is thermal bridge. And then the last one is, what is a residential building? As far as the energy code goes, all buildings, residential buildings other than hotels and motels, 3 stories or less above grade, are residential buildings. So you can build a 3-story apartment building or a 2-story apartment on top of a retail space, and that portion that is residential is built out of the residential energy code, even though the remainder is built out of the IBC, NEC, IPC, IMC, and IFGC. One last comment on continuous insulation. Continuous insulation greatly reduces the risk of condensation forming in walls or on roofs. And we will touch on that a little bit more here in a minute. Climate zones. Climate zones are based on county lines. It simplifies, but it is not completely accurate. While I was working at the county, we worked on this building that they built on top of the summit at Snowbird. This is at 11,000 feet. And Utah County line is just within a couple of 100 feet of the south of it. And I think it's Summit County that's on the other side of it, not too far away. But it is still climate zone 5, even though if you look at the climate, it more closely represents climate zone 6 or 7. But for simplification, the energy code went to back in 2006 to county lines rather than trying to narrow it down with a closer focus. And the climate zone is reflective of the major portion of the population. So if you're building at 10,000 feet, but it's in climate zone 5, you just might want to consider that, yeah, by code, we're climate zone 5, but maybe I ought to build like it was climate zone 7 and be a little more aggressive on my insulation for that building. This is like a 20,000 square foot building up top there. If you haven't seen it, it's quite an interesting building. Certificate. And I'll admit that I wasn't too aggressive on this one when I was inspecting. But as I think back through my career, if I'd gone into an existing home to replace a furnace and air conditioner, it would have been really nice if I had an identification method to know what kind of insulation is about in my walls or in a floor or in a roof, and what the windows were. So this is a label that's actually automatically printed by ResCheck, and you don't have to use this exact label, but every home should have a label certificate posted someplace. And it was originally, they said, put it in the electrical panel. Now it is suggested you put it in a mechanical room or someplace where you can see that. And it's simply to identify how the building was built when it was first built. And I think it's probably a good thing for a little bit of accountability that, yeah, well, I did put R19 in that wall, or I did put R60 in the attic. Prescriptive table that we mentioned earlier. I took out just those portions that apply to Utah. If you remember the map of Utah just a few slides back, climate zone 3 is Washington County, the St. George area. And you will notice that the walls require a little bit less insulation. The windows don't have to be quite as good as the windows for climate zones 5 and 6. We don't have a solar heat gain coefficient requirement for climate zones 5 and 6, but in a cooling dominated market, they do have a solar heat gain coefficient requirement in St. George. Attic insulation, again, higher in the higher numbers. The higher the number, the colder the climate, the lower the number, the warmer the climate. So 1, 2, and 3 are more cooling dominant markets, and 4, 5, and 6, and 7, and 8 are, get progressively colder. I think there's something interesting to note here. If we come down here on wood frame walls, for 3B, it is R20 or 13 plus 5. What's 13 plus 5? That's 13 in a cavity in R5, continuous on the outside. Same thing for 5. Climate zone 6, however, says R20 plus 5, R13 plus 10 are your two options. Notice that climate zone 6 does not, in the prescriptive table, have an option where you just insulate the cavity. They want you to put continuous insulation, at least R5 and preferably R10, on the outside of the building. Why would they do that? Because we want to reduce the risk of moisture condensing on the backside of our OSB. Let's think a little bit, and many of you have seen this, and you'll see it again. But if you have a wood frame wall with 2x4 and 2x6 with fiberglass insulation, any moisture that we generate within our house that manages to migrate through the wall, through the insulation, and it contacts the backside of the OSB on the exterior, the OSB, the exterior sheathing on your wall, has the potential to condensate. What's the temperature of that OSB that's on the outside of the insulation? The inside surface facing the inside of the house is cold, and if moisture condenses, it's going to condensate just like a cold drink with ice in it. Same thing is going to happen inside your walls. And so in the colder climates, 6, 7, and 8, the prescriptive table wants you to put continuous insulation on the outside, which raises the temperature of the backside of the OSB, the inside surface of the OSB. Completing the prescriptive table, mass walls, those are concrete walls, log walls, heavy timber walls. Our floor R value, that home that has no insulation in the floor with a vented crawl space is in climate zone 6, and it should of course have R30 in that floor. Basement walls, first number is if it's continuous insulation or a blanket. The second number is if it's a cavity. And our two colder climates are 15 and 19. And then slab edge insulation. Climate zone 3 doesn't require it, but climate zone 5 and 6 require R10 insulation around the perimeter of the slab, coming to top of slab. If it ends underneath the slab and doesn't give a thermal break, it doesn't count. 2 feet deep in climate zone 5, 4 foot deep on climate zone 6, just because of frost depth. Hatches, attic accesses. Big source of air leakage that we tend to ignore. This has been in the code for enough, I think, through at least 2 code cycles. That attic access, number 1, is supposed to have the insulation attached to the door, because if it isn't attached, first person through that attic access is going to push it off to the side, and it's never going to end up back on the hatch. So it needs to be attached to the hatch. For mine, I just glued a bunch of polyiso foam board on top of it to get the R value there. Needs to have a gasket around the trim, and if it is, the insulation needs to match the value in here. But the thing that we sometimes get hung up on is if your access is in a short wall or even a tall wall, if your access is a door, then it doesn't have to meet the R38 or R49. It only has to meet the requirement for a door, which would be like a 0.32 U factor door. I think we missed this one, and it's a pretty easy thing to do, but it makes a big difference, especially if we get that insulation attached there so it's always there. And if we get that, just a little piece of foam weather stripping around there. I can guarantee you that there are thousands and tens of thousands and hundreds of thousands of homes that have that big piece of fiberglass insulation sitting off to the side rather than sitting on top of it. And I'm probably guilty of having done that before, because you don't want to have that insulation falling all over you as you crawl back in. Going down through our guide, we get to another amendment, and we talk about air leakage. And air leakage requirements in 402 give us 2 options, and this is amended. The 2 options are, we either comply with all the items in table 402.4.1.1, which is this table, and unless you have a big screen, you're not going to be able to read it very well, but it's right out of the code, either chapter 11 or the IECC. And we have The component identified, we have the air barrier criteria, how we're sealing the air, air sealing the building, and installation criteria. So what the amendment says is either do this whole list or blower door test the house. And there are a number of things on here, and I'm just going to go down the list real quick and read them off. And then we'll talk a little bit more about a couple of them. I summarize these further on. This list is not in the guide, just a summary of the list. So ceiling and attic, we have a discussion here that the air barrier at drops and soffits and stuff like that should be aligned with the insulation. I have a picture that I'm going to go over on that one. Access openings need to be sealed. Insulation in any drop ceiling should align with the air barrier. And so they kind of go together, the insulation and the air barrier. But there's a couple of, and we'll just talk about the summary. I'm not going to take the time because I don't want to run out of time. But there's a couple of key ones that I do want to touch on. And one of them is rim joists. If you choose not to blower door test, the rim joist requirement is rim joist shall include an air barrier. Now the insulation requirement is rim joist shall be insulated. Well, we know a rim joist is supposed to have insulation in it. And how do we insulate a rim joist? We take a piece of bad insulation. Maybe you have a stick and you shove it up in there and you insulate the rim joist. However, this table says that rim joist shall include an air barrier. An air barrier on fiberglass insulation means that it's enclosed on all 6 sides, top and bottom, the 2 sides, back side and face side, with an air barrier, something that stops the air from moving through it. It's just like putting on a sweater, but if you want to go out in the wind where the air is going to be moving, you need to put a windbreaker over it. You got to complete that air barrier. So how do we put a piece of fiberglass insulation in a rim joist and put an air barrier over the face of that fiberglass insulation? You take a piece of OSB and cut it to fit, and then caulk or foam around the edges on every single one of them? Do you take a piece of Tyvek and cut and fit and staple it in there and then seal the edges? You know, it's virtually impossible to put an air barrier on a piece of fiberglass insulation without being horribly labor intensive trying to put something, a piece of drywall or something over it and then sealing it. So really, if you're not going to blower door test, if you are going to follow this table, I don't know of any other way that you can comply with that table other than spray with closed cell foam. That is the only way that I know of that you can comply with that, except is if you put the foam on the outside of the building. If you put the foam on the outside of the building, then you comply. There's nothing that says, there's nothing in the code that restricts you from putting R15 or 20 on the outside of the building. You just have to deal with how are you going to fasten your coverings on the outside. You can do an EFIS system, you know, the foam on the exterior of the building, and stucco, an EFIS stucco system, and have all the foam, all the required insulation on the exterior, and not even have any insulation in the cavity. That'd be perfectly legal. That's not going to be typical because that poses so many challenges. But for our discussion, if you're using this table, that's one of the things you're going to have to do. The other things you're going to have to do is make sure in your walls that you can insulate in all of your corners, you can insulate your headers. There's a number of requirements. The interesting thing about all of this is if we did not amend the code, we would blower door test and we would do the table. And so because the code is amended, we have the choice. We blower door test or we do this. And so blower door test. I think most of you are familiar with blower door testing. I'm pretty sure Jeff, right there in the center of my screen right now, Jeff Williams is familiar with blower door testing because that's what he does all the time. And there's others that might be on. I can't see everybody on my screen. Our HERS raters all do blower door tests, and they do them every day. And they simply depressurize typically the whole house, take it to 50 pascals, and see how much it leaks. And if you leak too much, you don't pass. And if you're tight, you pass. But if you're tight, you have some other things you need to deal with. So the code and nationally, the experts recognize that what we really need to do is do this table. And if you do everything on this table, and then you hook your blower door up and do your blower door test, you're going to pass. And it's going to be a nice tight house, and you're going to reduce your energy consumption, and you give yourself the ability to really control your air quality mechanically rather than having uncontrolled leakage in and out of your house. So that first option is the air barrier, or the second option is your blower door. Or you can say your blower doors first. It doesn't really matter. You have one of those two options. If you're not blower door testing, if you did not select that, you have to fully comply with the entire table. And so if they are coming in to pull a permit in your jurisdiction and you're the building official and they say, well, I don't want a blower door test, then that table should probably be their checklist that you give them, that that's what they're going to need to do. Now, I'm not saying that we shouldn't spray foam in all your rim joists. I think in any case, you should be doing it. I've seen more mold and such growing in rim joist areas because that's a real source of air leakage and one of the poorest insulated places. And that's because we don't have an air barrier over the insulation. We don't have the windbreaker that is stopping the airflow through that insulation. So that air barriers, my summary here is insulation and air barriers installed in accordance with the manufacturer. What does the insulation manufacturer say about installing batt insulation? They say cut it around the boxes, cut it around the wires, cut it to fit around the pipes. How often do we see them do that when they install insulation? A continuous air barrier. We've talked about what some of those things are. All gaps and voids sealed between conditioned and unconditioned spaces. Does that mean the wall between the garage and the house? We need to recognize fiberglass, rock wool, and cellulose are air permeable. Air moves through them, and so we need to seal those. Closed cell foam is really the only insulation that I know of that really serves as an effective air barrier. Drop ceiling, soffit, shafts, and chase shall be capped. Let's think about this a little bit, and maybe I have a picture, but it's not the best one. I need to drop a graphic. If we put drop ceilings in closets or wherever we put them, or we put in scissor trusses and then we drop ceilings in some areas, we have this area where the ceiling line comes up and then it drops down and then it goes across, then it goes back up. And the insulator comes in and he insulates around on the walls, and then some blown insulation is going to come down on the bottom of the drop. And we've got a mess. The insulation doesn't stay in place. The insulation, vertical insulation, does not have an air barrier on the backside, and it falls out. And we have all these places for air leakage. What this table is really telling us is we should have a lid going across our entire ceiling. So if we have scissor trusses and we're dropping in places, anytime we drop down, we should put a lid in there. We do it if we have a chase going all the way up through, but we should put a lid in any of those drops. If we drop for a bunch of ductwork, we should have a lid in it first. And then when they come in and blow the attic insulation, it's continuous attic insulation without any of this dropping down and going back up. It's a cleaner job, and it's much more efficient and effective at insulating. And we eliminate a lot of air leakage. So put a lid in the bottom, in the top of these drop down spaces, so we have a continuous air barrier at the ceiling line, the bottom of the truss. and we solve a lot of problems. Walls need to be framed so you can insulate the corners. Wall insulation shall be enclosed on 6 sides. I've already talked about that. That includes knee walls. The back side of a knee wall for a bonus room has to have an air barrier on it. Cut and fit around pipes. I really like blown insulation because I think it solves a lot of those problems. Rim joist, we talked about already. Recessed can lights and such need to have those penetrations sealed where they penetrate the air barrier. Your ceiling is your air barrier in most houses, and that needs to be sealed. We need to be aware of our fireplace tubs and shower areas and make sure we have continuous air barriers there. And air sealing provided between garages and conditioned spaces. This one we miss so much. We put Tyvek all around the house for an air barrier and a weather barrier, but we don't focus on making sure we seal that wall. And then what do we have? If someone leaves a car running in the garage or a charcoal grill, oftentimes we have a fatality inside the house because that is a leaky component of the envelope. Insulation should be in contact with the underside of the floor or on top of a lid below, and air barriers on the underside of cantilevers. And I have a picture of that. That's a very important one. Or you do a blower door test. So you do all those things, or you do a blower door test. Now here's a big one. And this is the one that I think a lot of the people that are online didn't realize until maybe they saw the announcement for this class. And I'll be honest with you, I didn't catch it until just a month or two ago. For many years, oops, too far. For many years, the last 4 years, we expected that on January 1, 2021, this number, 3.5 air changes per hour, was going to change to 3 air changes per hour, because that was the original number put in the first batch of amendments. So we started out at 5 air changes per hour about 4 years ago. We dropped to 3.5 air changes per hour January 1 of 2019, and we were expecting to go to 3 air changes per hour at the first of this year. And I dare say some of you have probably been enforcing that or asking for that. However, when 2 years ago, when we saw an amendment take place, at the time we went to 3.5, the industry that builds townhomes was concerned, and others, HERS raters and everybody else was coming to me and say, you know what, we got a problem. It's hard to get down to 3.5 air changes per hour on a townhouse because that common wall, that party wall, we don't seal up like we do our exterior walls. And so they were leaking between units. They weren't leaking so much to outside, but they were leaking to units. And so at that time, the code was amended to 5 air changes, stay at 5 air changes per hour or less for townhouses and multifamily. Well, at the same time, they just dropped the amendment that went to 3 air changes per hour. And so with this modification, preventing townhouses from going to 3.5, they just took out the little half sentence that was going to drop us to 3. And 3 was printed on my previous guides, and we all just assumed we were going to go to 3. Well, that didn't happen. It was deleted, and we are still at 3.5. So big clarification, we did not go to 3.5. Now that does, we did not go to 3, we're still at 3.5. That does give us a little pause when we look at mechanical ventilation. And that one we're going to talk about here in just a second. Because once you hit 3, then you have to do mechanical ventilation. You have to have a ventilation system that's always continuously providing a little bit of fresh air in your house. And I have a little graphic here of one of the fancier devices with blower doors that tells the pressure. They've taken the house to a negative 50 pascals, and at that pressure, it leaks 3.31 air changes per hour. Now, this is not in the energy code. This is in the Chapter 8 of the residential code, and it's also in the IBC for commercial buildings. Remember me talking about condensation occurring on the backside of the wall. The condensation problem is more severe when we get into roof systems, especially rafter systems, where we do not have an attic we can ventilate, or it's difficult to ventilate the airspace because of dormers and gables and such above insulation in a rafter. And so what do? We net and blow it and fill the whole thing full of a fiberglass insulation or some other type of insulation. The moisture that rises with the heat, if it gets through the drywall, which it will, or the can lights or whatever, and contacts the underside of the roof deck, it's going to condense. The roof sheathing is cold. And so we have this condensation occurring on the other side of that underside of that roof deck. We have in the residential code that if you have this unvented enclosed rafter or unvented attic, you need some form of air impermeable insulation, closed cell foam or rigid board, either installed on top of the roof assembly or on the underside of the roof assembly. So you either need to put rigid foam on top like we do on flat roofs all the time, or you need to put some spray foam on the underside. And depending on your climate zone 5, it's R20, climate zone 6, it's R25, climate zone 3, it's R5. And this simply is to keep the underside, the first surface that moisture contacts as it migrates up through the insulation, the first thing it hits is a warm surface. If it hits a warm surface, it's not going to condense. Have you ever watched what a roofer does when he does a roof replacement? He walks across the whole roof and he looks for the spongy spots. Then after he strips the roof off, what does he do? He typically replaces some roof sheathing, and is replacing roof sheathing that for one reason or another, it had moisture condensing on the underside or it leaked through from above. Lots of times it's from bath fans that used to just blow into the attics. Whatever the case, if you have cold OSB or plywood and moist air comes in contact with it, it's going to condense. And this is going to happen in these unvented attics and unvented enclosed rafter assemblies. Please contact me if you have a question on that. I have some handouts on that. In fact, maybe I'll do a blog on this one just to describe that a little bit. I've talked about it in other classes, but this is really, really, really important. I know up in the higher areas in Summit and Wasatch County, there's been a lot of problems with this over the years because that's how they like to build a house. They like to build with TJI rafters. So you have high cathedral ceilings and big windows that look out over the mountains. And then you end up with a condensation issue. Fireplaces. If you've attended a lot of my classes, you've heard me call these wood-powered exhaust fans. And that's what they really can be. And we all know how much air they'll draw out of a building. And we have some challenges installing wood-burning fireplaces with our current code. We're building a building tighter and tighter and tighter, and we simply cannot supply the combustion air to them. I bought my first home in 1975, and it had a masonry fireplace. It was a new home, and that was one of the selling features. And even that home with junky windows and no attempt to air seal, when I got a fire going, it was powerful enough that it reversed my B vent. You'd walk downstairs, and if my furnace or water heater turned on, the product's combustion did not go up the vent. They came into my house. And it happened to all of my neighbors. There was like 400 of us in this subdivision, same type of house. And every one of them, if you build a big fire, you had a problem. And so what you did is you cracked the window in the living room a little bit to allow combustion air. So here we build a house 10 times tighter and we try to put in a wood burning fireplace, we're going to have an issue. The energy code says you have to have tight fitting doors. Chapter 10 in the residential code says if you have a factory or masonry fireplace, it has to have an exterior air supply to ensure, proper combustion, unless the room is mechanically ventilated or controlled so the indoor pressure is neutral or positive. The only way you're going to have that room where the fireplace is neutral or positive is if you're mechanically forcing air into that room, or you are going to have doors that are sealed and you're going to supply the combustion air inside the sealed doors. Those are the only ways you can really comply with the code, and that's the only way they really are going to work. Rooms containing fuel burning appliances. This one it's never made sense to me, and so that's why a number of us here in Utah and across the country finally got together and we put we proposed it and got this approved in the code. So basically, if we go down in our basement, we just have a furnace and a water heater sitting there in our basement. And there's a combustion air duct up behind here. You can't see it. We've really defeated the purpose of air sealing our house. So we've sealed the house and then we have an open combustion air. So the solution is if you have appliances that need combustion air and you supply the combustion air through an opening to outside, you need to enclose this into its own separate room, insulate it, put a threshold on the door, seal it all the way around, which would mean a ceiling too, or ceiling in the joist, and create an old a separate environment for that room. And that way the open combustion air duct isn't communicating with your house that you just tried to air seal. And that combustion air duct that's coming across into the room, you need to insulate that duct where it comes across the room. I don't think this is being enforced very much. I think there's a lot of systems that go in. We do all this, make all this effort to air seal, and then we still have a 6 or a 7 or an 8-inch pipe or hole cut in the wall that kind of counters everything we just did. Looks like I had a question here. I'm gonna have to put on my glasses to read it. I probably missed it a little bit ago. Is an air barrier required on the underside of a garage floor ceiling assembly? Well, the garage floor ceiling assembly, so I think Andy's talking about you have a garage with living space above, and that's an insulated floor ceiling assembly above. Do you need an air barrier? Yes, you need an air barrier, which is your drywall on the underside. So you have insulation, the insulation in that cavity, and the code says you either put the insulation up against the floor or it can be down against the sheetrock. Preferable would be just to fill it full of insulation, but the code does allow you to have an air space above or below it as long as you have the air barrier there. Recessed lighting. Either the can light it needs to be an airtight can light, and it either has a gasket on it or that we make some effort after to caulk and seal the opening. And these are a couple of the more minor things. They're not the big ones, but they're simple ones to check. There's also in the code, and I don't have a graphic with it, a maximum fenestration U factor or soil heat gain coefficient. The code says, yeah, you can use a crappy window or a cheaper window, but you can't use a horrible window. And so if you put standard double pane glass with no low E coatings or anything, you might end up with glass that has a 4.5 or 4.7 or 4.8. Well, if you take all your glass and do an area weighted average, it has to be a 0.48 or lower for climate zone 5 or a 0.4 or lower in climate zone 6. Now we do have an exception for like stained glass if it's small and a few things. We have a maximum also on solar heat gain coefficient. It can't be any more than 0.5 for climate zone 3B. Just for those that might not remember, windows are rated with U factors, and a smaller U factor is better. U factors are the reciprocal or the inverse of R. And so an R, if this was 0.5, an R 0.5 U factor, you take the reciprocal 1 divided by 0.5, and it's 2. So a 0.5 window is an R2, a 0.33 window, which is a good U factor, is an R3. A 0.2 window, 1 divided by 0.2 is 5. So that would be a triple pane window, and that's a good window. So the smaller the U, the better. And our typical U factors, if you look at our prescriptive table, are in the 0.32 range. You can have a little bit poorer window, but you can't go clear up to this area. Duct insulation. I get a number of questions about, can't you use R4 for return? That goes back to 2003 code that you could use R4 for returns. You cannot use R4 for returns anywhere. It's R8 for any ducts in the attic or outside, R6 in other areas such as crawl spaces and garages. Duct sealing and testing, another big one. Number one, duct sealing. Now, I don't know how many, I know there's HVAC people out there. I see my friend Ryan there. Here's an elbow that's been tapped into the top of a duct. And plain and simple, that is a sloppy installation. It's a terrible job of doing the dovetail into the top of the duct. And then they decided, well, we did a crappy job, but we'll throw some duct sealer on it. And then they did a poor job of trying to put duct sealer on it. When I called this one out on an inspection, the guy says, well, you can't expect me to make everything tight. Well, I beg your pardon. I think I can expect that to be tight. I don't think you'd want that on your house, would you? With the air leaking like that. And so duct sealing, it's not that hard if you think about it as you're putting it together. I can almost guarantee you when this elbow was installed in the duct, they cut it in, they cut the hole, and they put the elbow in before they put this piece of duct up. I see someone nodding his head. Yeah, they're hard to cut in after. You cut them in. Scott there has probably seen me cut these end ducts before. And I cut them in and then I put them up. And what we did was when we cut them in, we sealed them while they were down below. It just made it so much easier because you can see this guy didn't run the sealer around the backside where he can't get to it. It just takes a little bit of effort to do a good job of sealing. The other piece of this, and this is something that I really believe gets missed a lot. And this has been updated January of this year. If you have 20% or more of your duct located outside the thermal envelope. So if you have a bonus room and you have duct running in the attic to get to the bonus room, and that accounts for 20% of your duct system for that system, then the whole system needs to be pressure tested. If you have a furnace in an attic or in a crawl space, the whole system needs to be pressure tested. So at least 20% of the duct outside the envelope, and lots of times it's all of your duct is outside the thermal envelope, or the air handler furnace outside the thermal envelope, you need to pressure test. Now, why is this such a big deal? Because when it's located outside your thermal envelope and the duct leaks, we're throwing away air that we just spent money to heat and cool. And if the return duct's leaking, we're sucking in whatever the attic temperature is. So if we have a big return leak and we are sucking in 140-degree air into our return system, you HVAC people know very well that if you have very much of that, your system's not going to work at all. And if it's just a little bit, you're really impacting the operation of your HVAC system. When you go to your design guides and your expanded data for your air conditioning unit, it looks for entering air temperature, the entering air temperature that is entering the evap coil on the air conditioner. And the hotter the temperature, the less capacity you're going to have out of that air conditioning unit. And so duct systems in attics or in crawl spaces simply need to be sealed and they need to be tested. So, I mean, there's a couple of things. If you just pick one thing to start with this month, whether you're a builder or an inspector or whatever you are, or a design professional, let's make sure that we identify that any of these duct systems that are outside the thermal envelope are tested to make sure they're not leaking. I will add that the leakage rate has been amended in the state, and you're allowed twice the leakage that the code allows. So how do you test a duct system? Well, here's a furnace that they're testing the duct system, and it's kind of like a blower door. You mask over all your registers and grills, and you install a temporary panel over your furnace blower compartment, and you pressurize the duct system. And by simply measuring the amount of air that is required to keep the duct at that pressure, you can calculate and identify how many CFM per 100 square feet of house, how many CFM is leaking. Now the number is 6 CFM per 100 square feet. So if you have a 2,000 square foot house, 20 times 6 is 120. Is there anybody here that wants to just throw away 120 CFM when you just barely spent the money to heat and cool it? I mean, you didn't even get any benefit out of it. I mean, if you at least blew it into your house and then it leaked out, at least you got some warming benefit, but you just threw it away before you even saw any benefit in your house. It was heated or cooled, the energy you put into it, and then thrown away. That's kind of crazy. And we have houses that are bigger than 2,000 feet, so you can have a lot of duct leakage and you're throwing a lot of air away. I kind of cringe when I think about it, you know. And I put in thousands of systems that they have me put the duct in an attic. I hope we sealed them well. We tried. The code itself says you cannot use building cavities as plenums or ducts. It's been amended. The plenums have been crossed out. I don't think the amendment is very clear, but the intent of the amendment, and this is the way I'm going to present it, and that's the way I'm going to interpret it, is the amendment says the intent is that you can still pan a joist. That being said, I was with one of the other, and I don't know if Mitch or one of the people that work with Mitch is online, but I met Mitch on a job a month or two ago where we tried to do this test, had a big duct system, and the return air was leaking so much on that house that we could not perform a test. We could never build any pressure in the duct system. And the duct system didn't look bad, but because they had pan joist and they were drawing return air up wall cavities and you have wires running through and holes drilled, you simply you couldn't get any pressure in it. So fortunately it was inside the house on this one, but we had to block the return side off. So we pulled the filter and put in a panel so that we only pressurized the supply side. And then we were able to pressurize the supply ductwork, but we could not pressurize the return ductwork. And that's why the code says don't pan joist. Well, we can pan joist. If you're panning joist and then you have a bunch of duct outside your envelope going into an attic, you're going to have a real hard time passing your test. And I think Jeff and others have probably had that experience where if they've had pan joist, it's pretty tough to pass a duct test. couple of probably less frequent, but still around a little bit, mechanical piping systems. What's a mechanical piping system? That would be our boilers, our radiant heat systems. Those areas that are not radiating heat into the living space need to be insulated to R3. So if we put in a system and our main lines running out to our manifolds should be insulated to R3. Our circulating and demand hot water systems, when we're putting a CERT pump on, and we really need to look closely at plans. And if you builders and you're putting one in, you need to identify it on your plans, or at least recognize that when you put them in, that entire loop should be insulated. And that's identified in hot water pipe insulation. And so in the commercial code, we insulate all of our hot water pipe. In the residential, we identify just larger sizes. Those recirculation loops need to be insulated. Under slab, however, under slab is amended out in our state. That's an exception. And apparently the plumbing contractors in Washington County, where they run a lot under slab, voiced the opinion that that was really expensive for them to insulate it. And so the legislature pulled it out for them. If you put one of these recirculating systems in, they have to have controls that either shut it off at times so it doesn't run all night when you're not using hot water, or some type of demand sensing. So we have some requirements there, and we probably miss these most of the time. And we're even missing this one. And you should go to that section of the code and look at, there's a list of like 8 different locations that you need to be insulating hot water pipes. Mechanical ventilation. Here is what I was talking about. When we build tighter, we need to mechanically ventilate. And this is what ties in kind of with the code change that didn't happen, us going to 3 air changes per hour. I've been talking a lot about building a tighter envelope. And if I asked the question and you were all live, or if I asked everybody to raise their hand, and I'm not going to do that, but can you build a home too tight? 20 to 40% of you say, yes, we can build a home too tight, maybe even more. And I'm going to share my opinion is I don't think we can build a home too tight. What we can do is we can build a tight home and fail to ventilate the home. So I'm here to suggest that we should build our home as tight as possible, then we should mechanically ventilate it, because then we can really control removing the contaminants from the house, and we can control exactly how much fresh air we add to our house to maintain air quality. If we build it loose, we think we're improving our air quality, but we really are not, because what are we doing? We've got the outside walls and we're exchanging air back and forth at our outside walls. Maybe if the wind's blowing, it blows all the way through and it flushes the entire house. But generally, if we don't have wind, we are just doing this thing back and forth through our walls, and we really don't exchange the air in the middle of the house, and we don't take care of the contaminants. It's kind of like opening the windows at night and turning off your air conditioner. If there's no breeze or anything, you know, we have some relief right by the windows, but we don't cool down in the center of our house unless we move the air through the house. And so mechanical ventilation by far improves the air quality in our house, so much better than trying to naturally ventilate it either through air leakage or by cracking a window. So 403.6 talks about mechanical ventilation, and it refers you to the IRC in Chapter 3 and the mechanical section of the IRC, where it talks about whole house ventilation. And basically these 2 sections of the code tell you either need to naturally or mechanically ventilate the house. And this section 1507 tells you to mechanically ventilate if the house is tighter than 3 air changes per hour, which is in red text over here. So if you are 3 air changes per hour or tighter, a lower number, you have to mechanically ventilate. So that's starting to get pretty tight. So we have to mechanically ventilate according to state amendment at that point. The blower door option, if you choose that blower door option, the blower door test requires you to reach 3.5 air changes per hour. So you build a fairly tight house, so you pass that 3.5 test rate. What if you build it tight enough that you hit 3 or lower? Then you have to mechanically ventilate. You're required by code. I want to look at it another way and not use the word that you have to mechanically ventilate. Without an amendment, the code says when you get to 5 air changes per hour or 40% more leakage than this number, when you get down to 5 air changes per hour or tighter, you're supposed to mechanically ventilate. So what that is telling us is those people, everybody involved in code development, and there's some pretty smart people, the Stebricks and other people that you may know their name, Joe Stebrick and others, that I've identified. Once you get down to 5 air changes per hour and tighter, that's the time that you need to start providing mechanical ventilation because your house is getting tight enough. Now, our legislatures decided that you don't have to do that until you get 40% tighter than that. Might I suggest that we should mechanically ventilate every home we're building right now so that we don't have excessive moisture in our house, we don't have an air quality problem, we don't have as many mold problems, and we take care of that. However, if you want to go exactly by the code and you are doing a blower door test, you need to be aware that if you hit that 3 number or lower, then mechanical ventilation is required. And for code officials and everybody else, you need to be aware of that. Without amendments, every home in Utah would be blower door tested. Every home in Utah would be mechanically ventilated. And every home would have better air quality and would have a lower utility bill because it would be more efficient if we did all those things. So those, and we're going to talk a little bit more about mechanical ventilation in the next slides. Those intakes or those exhaust openings that go through our building envelope, because we're talking so much about air barriers, need to have some type of backdraft damper in them. So let's jump on to the next one. So if we decide we're going to do a whole house ventilation system, what is a whole house ventilation system? It is a system that runs continuously. We're constantly providing a small amount of fresh air into our house. And how do we typically see that? Well, the most common way is they take a high efficiency, quiet, and some of you have seen these and some of you use these. Panasonic makes them and other companies make them. This small fan, and maybe it's in a hallway or maybe it's in the master bathroom or maybe it's a combination of 2 fans, and they are wired hot to run all the time. And they are constantly exhausting 30 or 40 or 50 or 60 or whatever's required for your house. And the code gives us direction based on the number of bedrooms, how much air we should be ventilating, exhausting and replacing in our house. So if we have a fan running continuously, it definitely does not want to be that $14 cheap fan that we buy at Home Depot, is it? Those things would drive us crazy, and they'd probably last 2 months and then they'd fail. They're horrible. They don't move any air. I could go on for the next hour about everything that's wrong with those fans, especially when you put flex duct on them and they move even less air. And there's a whole nother discussion and another whole nother set of code requirements for that. But there are these fans, and they literally don't draw about the same amount of current as a doorbell transformer that can just ventilate, exhaust a small amount of air. You wire them continuously. You have the option to have them go to a higher speed if it's your bathroom fan, either by a switch or an occupancy sensor or a dehumidistat. And they just provide you fresh air all the time. If you have an exhaust fan running, it's going to be exhausting air, and that air is going to be replaced by leakage. Of course, we could do a heat recovery ventilator where we exhaust some and we supply some in and we exchange the heat. If you're not familiar with heat recovery or energy recovery ventilator, go to YouTube and watch a video or two on them. That is the premier way to do it, but it's going to cost you more money. This is an affordable method. In any case, we should mechanically ventilate our houses. As we build them tighter, it's imperative that we mechanically ventilate our houses. And if we choose to do that, we have a table, and this table actually comes from the 2018 Energy Code, or IRC, and it was put into our code 2 years ago with a couple of the other changes that took place. And you can credit Kevin Emerson at Utah Clean Energy for convincing the legislature that this needed to go in. And all this table says is, if you use an HRV, a range, or an inline fan, or a bath fan, or a utility fan, depending on the CFM, we have a minimum efficacy for that fan. So basically it's saying if it's an ERV of any CFM, you have to provide at least 1.2 CFM per watt. If it's a range fan or an inline fan, it's 2.8 CFM per watt. That's pretty darn good. And a bath fan that moves more than 90 CFM, 2.8 CFM per watts. And so it's simply saying, we're going to move a certain CFM, but we want to make sure that we're not consuming a large amount of energy to remove that. And so this is in the code. So if someone chooses to put in a bath fan for their whole house ventilation, we simply need to make sure that it's an efficient fan. And the Panasonics and the Braun high efficiency fans and the Newtone high efficiency fans, and there's some other companies, and I can't pull their names right off the top of my head. Most of them make fans that fit this requirement, and they draw very, very little. They simply just do not draw that much power. And so most of us aren't familiar with it. We need to make sure that any of these, especially HRVs and ERVs that are going in, meet these efficacy requirements. As we're nearing the end, and we're going to make it in time, maybe a few minutes early, equipment sizing. I don't need to say anything more about manual JDNS because many of you have heard me carry on about that a lot. But if you have some questions, give me a holler, and watch in the blog for discussions on that. Snow melt systems. I did a class yesterday up in Clearfield, and we had some people from Summit and Wasatch County, and the conversation went down the path. Okay, we're building this really efficient building, and then we put snow melt in it and put a $2 million BTU boiler in to melt snow. What about the efficiency of that? Well, that's another discussion. However, if you do put in a snow melt system, you have to put in the snow melt control that's poured into the slab that senses the air temperature, slab temperature, and moisture. And so the system only runs when the conditions are that we have moisture and it's cold enough that we have a freezing potential. Otherwise, the system doesn't run. Pools and in-ground spas, we have some requirements on ready access to switches, timers that shut off pumps and such. When the pool is not in use, there's a lot of horsepower and a lot of energy used running pool pumps, and pool covers if the pool is heated, with some exceptions. Lighting, 75% of the light bulbs need to be high efficacy. When this first came into the code, 5, 6 years ago, LED lighting was pretty expensive. It's a no-brainer now. And you can get all different color spectrums and everything. So our lighting has drastically improved. The simulated performance model, that's third-party modeling. We talked a little bit about that before. It's based on a standard reference design, as I mentioned. And HERS ratings, or our ERI path. I just wanted to add a little bit more information on this. You can go back into previous presentations and we talk about some of these more in detail. But a HERS rating is a score, and a home built 2004, 2006 is a reference home that has a score of around 100. And so that's our reference home. A home built at that time to the code has a score of around 100. As you go to 0, every step is a 1% improvement in efficiency. So a 0.65 home is 35% more efficient than that home from back in the early 2000s. When we get down to the 30 range, that's when we're getting into the range that they recommend if you're looking to go net zero, where you try to meet most of your energy needs with solar panels. When you get down into this 30 and lower range, then you can meet most, if not all of your energy needs with PV panels without having to put them everywhere in your yard and everything, with a reasonable number of panels. So this is a great method of scoring a house. Wouldn't it be great if we scored every house, new or old? And yeah, your old house might be 150, but if you did improvements and you dropped the score down to 90, then your home would be much more appealing than it was at 150, and you could get your money back for the improvements that you made. These numbers are amended. You know, it's a little looser than the code numbers, but it's still a great method. With the HERS rating, or the ERI path, as we can call it, either one, you can get away with things that you can never get away with the other methods. And the one that comes to mind is down in climate zone 3. We see a number of people that want a view of the red rock. And so they build this big, beautiful home, and they want to put up on one wall, butted glass. And you might have seen it as 1/2-inch glass that they just butt together. So there's just a little tiny seam that they seal. And so you have a whole wall of glass. And actually, with the ERI path, doing a HERS rating, if they don't have too much of it and they go overboard on other insulation, I shouldn't say overboard, but go to extreme measures on other areas of the home, put in high efficiency appliances, high efficiency HVAC equipment and lighting, and get credit for all that stuff, they can actually build that home that has what is really a poor window, but gives them that great view. So it gives you some flexibility. Some final thoughts, and there's just a few slides I'm going to jump through real quick. Air barriers. Can a building be too tight? I maintain no, it isn't too tight if we ventilate it correctly. When we wrap the building paper, the Tyvek or whatever on this, and isn't it interesting that they miss the rim area, which is one of the greatest sources of leakage. And they've wrapped around the garage, and that's fine that they put it on the outside of the garage, but did they do anything on the walls separating the garage from the home? Airflow through the thermal envelope. Let's think about this. Our cantilevers, are we putting an air barrier on the other side here? Does the wind come up through this, through the blocking, because it's an I-joist, and just get into our house? Is this filled up tight with insulation? Do we have a boot coming out in here feeding a register up in here? Huge source of leakage, huge source of energy waste. Pressure differences in our house, whether it's the wind or the stack effect of air rising or fans, or we have a flaw in our HVAC system. We don't have return paths in every room. All of those will encourage excessive airflow through our envelope. And remember, if we take air out of our house or we put air into our house, we're going to have air, either coming in or going out to replace. So it applies to both controlled and uncontrolled air movement in and out of our house. Ducts in garage ceilings. This one's, we talked about duct insulation. If we have ductwork in this garage ceiling, which we have here, and you can see the fur down, too often they run all this sheet metal duct and then we just come in and we put bad insulation in between the framing. We end up with no insulation in this area. We have voids and spaces all over within this ceiling assembly where we don't have insulation. We don't have any insulation between, up above all of these. And if the insulation isn't enclosed with air barriers on all sides, it really doesn't work. My opinion, my interpretation, if you really want a duct system to be well insulated in the garage, either insulate it and then insulate the envelope, or do a bib net and blow system and completely fill the cavities with insulation. And this one works out really well. And the builders that do this are finding that they have far fewer problems with their bonus rooms above their garages when they put this system in. The whole garage is insulated this way, and we eliminate all the cold spots coming through the floor and through the ductwork in those garage systems. This one is an ivory home, and that's what they've chosen to do on their duct systems where they run through the garage. Completely filled. See the blog. I wrote a blog on this and go into a little bit more detail. Cantilevers. I had an experience in my house that I'm in now when I bought it. Wind blew, and all I had was soffit metal on the underside of this, and the wind would just come right up through and race across, and the hardwood floor inside the house was brutal. It was ice cold. A view from down in the basement. These are all areas where you have a cantilever going out, so we don't have the OSB sealing it off. So maybe they shove a little bit of fiberglass bat outside on the underside of the cantilever. Maybe they put something on the underside to stop the air movement through it. And then maybe they just throw a piece of fiberglass bat. How much air movement is going to be taking place? How well is that going to perform? It is not. We know that they have to cut these to get to their J bolts in the foundations, but they're not being sealed up. Perfect application for where we need that spray foam to seal up the rim. And we need to think about the rim that's on the other side, out on the edge, really out of the edge of the home. Fiberglass insulation is not an air barrier. If you pull drywall off or you pull soffits off or whatever where there's fiberglass insulation, it's going to be dirty because all it is a filter because the air is moving through it. So here's one of those again, and we can see the daylight through this. This is a bay window area. The supply air is going out there. Piece of insulation shoved underneath it. What is the chances that the rim joist is really insulated well out around the perimeter of this bay? How well is this really going to be insulated? Well, we saw the picture back here, 3 or 4 slides of how it's insulated there. Lots of open air spaces. Again, with open air space, it's like having the sweater and the windbreaker, and you don't zip up your coat, and we have cold air moving through it, and the insulation is ineffective. That duct is not insulated as it should be, the way it's installed there. Is there a minimum R8 or even R6 all the way around the duct? Is the rim insulated properly? And net and blow and then spray foam is probably the only way that you can really get that to perform the way you want it. And you have to make sure you seal the underside of that cantilever. Put a piece of OSB on it, wrap the Tyvek down underneath it, caulk it, whatever you got to do to seal it up. Here's an example of what we were talking about. Here we have a scissor truss roof system, and they've dropped it for a laundry room here. There's a drop here for the entry. And so we have insulation going across, and then it comes down this wall, then it comes across, then it goes back up, and we have this open space above it. And so the wind blows and it blows the insulation off and down into here. What that table is telling us is put a lid in all these fur downs. Now think of how much simpler it is if you put a lid, and it can be OSB. You put a lid up in there, up against the bottom of the trusses. You really eliminate the need for this OSB. This OSB has been put on for the air barrier on the back side of the insulation that needs to go here. How about we just put the lid in there, and these are just interior walls. You're gonna have to fire block them, but that's it. And then your attic insulation is continuous all the way over the top, and we don't have all the air leakage that's going to occur at all these different spots because we seal the lid around the edges. This house had fur downs everywhere, and in fact, it had so many fur downs. Instead of the furnace in the attic, it could have been in this space above the laundry room, and they could have ran the ductwork all underneath all the lids and got the ductwork out of the attic, which would have been a much more efficient system. So I'm preparing a blog on this one too. Simple thing that makes a huge difference. I can't even count how many times I've seen these little short wall areas that have insulation in them, and the insulation's fallen out and we have nothing, or the insulation is all blown off in this area down into this fur down area. That is it. I appreciate that, your attendance. I've got a question or a comment here. Let me go to it real quick. We still have a couple of minutes. The question in the chat is, you mentioned the closed cell spray foam is a great air barrier for rim bands and against the underside of cathedral roof deck. I agree completely, but I see open cell foam commonly used in the same areas. I'm sure the cost is a big reason why. I'm curious what your thoughts are regarding open cell foam. Are you aware of a good source of data specifications regarding the two forms of spray foam as an air barrier? Are you, let's see, it just jumped on me. And in joist and cathedral ceiling applications, also in cantilevers. Great question, Kevin. Some of the open cell foams, my recollection is that some of them, when you reach a certain depth, they achieve the perm rating that we're looking for tightness. You know, we're concerned about the air moving through it, but you know, with that, we're concerned about the moisture within the air moving through the foam. I don't know of one source. I think you would need to go to the manufacturer's information. I am aware that Icynene has they have multiple products, and some of them require less insulation, if my recollection is correct. So you don't need to have quite as much to achieve the perm rating that it would qualify as an air barrier, and it would stop the flow of humidity through there. Anybody else has anything? Here's your shot. Otherwise, I'm going to sign off, and I'm going to thank you. It looks like we were running around 80 people attending. That's, I think, probably a record for a virtual class that we've done during this time on energy code. Please reach out to me if you have any questions, and I will, well, let me just mention, we are going to be doing a class in St. George, probably at the end of April, and that's going to be virtual and live. And then in May, we're bringing Mark LaLiberte of Construction Instruction back in. And if you haven't heard him you need to, and if you have, you already know what he's all about, and you're going to want to be able to participate in that one. He's a building science expert out of the Colorado area, and has a ton of great information. So, oh, looks like I have one more. No, I think that was it. And that question was from Curtis, not Kevin. Thanks, Curtis, for the question.
There is a question about continuing education units, so I will report those to Doppel today. It usually takes about 72 hours for those to be recorded. So just check with Doppel next week to make sure your hours were recorded. And if you had your camera on and you gave me your license number, there shouldn't be any trouble, but give me a call if you do run into anything, and I'll put my phone number in the chat here.
And for those of you that are inspectors, this class has been registered with ICC as, you know, through WC3 as a preferred provider. If you want a certificate, you don't have to have it. You know, you can just go onto the website and just find the class and record your hours. But if you want a certificate, send me an email, and I'll make sure you get a certificate for it. But you, as you know, you self-report your classes through ICC, and it will be, in fact, it's already on the website. If you send to me for the certificate, it'll have the number on it, so it might be easier to find. Thanks again. One last comment. If you have questions, I'm trying to be a little bit semi-retired, so I don't work every day. If you email or text me, you might get your answer just as quick than trying to call me, because I'm not able to answer my phone all the time, whether it's for personal reasons or I'm teaching a class. But your questions are welcome. Just because I'm not here on my phone every minute, your questions are still welcome. Thanks so much. And thanks for the kind words, and we'll talk to you later.